This lesson is going to be on word problems. There are two new terms that I'm going to be talking about before moving on to some examples. All of the math that I'm going to be doing is the same math that you learned last week, so none of that will be new. The only thing that's going to be new when we're dealing with this is the fact that we are going to have to take some words and turn it into a diagram before moving on. The first new definition that we're going to be talking about is the angle of elevation. So the angle of elevation is the angle between the horizontal. So remember this, the horizontal would be this red line that I just drew in here, and the line of sight when one is looking up at an object. So angle of elevation, if you were standing here and you were trying to look at a cat up in a tree, the angle that your eyes would make if they looked straight compared to the angle that your eyes would make if they were looking up at a cat would be the angle of elevation. You'll see when we're talking about word problems, the angle of elevation doesn't necessarily have to be the angle looking straight from your eyes. It will often be the angle from the ground. The angle of depression is the angle between the horizontal and the line of sight when one is looking down at an object. So if you were to be standing at the top of a cliff and you were looking down to see a boat, that is the angle of depression. 99% of the time, the angle that you're going to need in a word problem when they give you the angle of depression is this angle that I'm coloring in blue right here. So you will often be doing 90, so a right angle, subtract your angle of depression. The first example that we're going to be doing today is Lincoln's kite string is 35 meters long. It makes an angle of 50 degrees with the ground. Let x be the horizontal distance in meters to the kite. What is the horizontal distance between the kite and Lincoln? The first thing that we need to do every single time is draw a picture of what's going on. So I'm going to be drawing Lincoln, first of all, flying a kite. Now, what do we know? We know that the kite string is 35 meters long. We know that it makes an angle of 50 degrees with the ground, and I know that I'm looking for the horizontal distance. Now that I have my diagram, the first thing that I'm going to be doing is labeling all of my sides. Now, I know right away this is my right angle, so I know the 35 is my hypotenuse. Since this is the angle that I am given, I know that this is my opposite, but I don't care about that, so I'm not going to label it. And if that is my opposite, it does mean that this is my adjacent. If I think about SOHCAHTOA, the formula that I'm going to be choosing has to be the formula that includes my hypotenuse and my adjacent. So I will be using cos. So cos of theta equals adjacent over hypotenuse. The next thing that I'm going to be doing is plugging in my information. Cos of my angle was 50 degrees. My adjacent is x, and my hypotenuse is 35. Now, if I remember my three examples from before, this is the example where x is on top. That means that this divided by 35 needs to come over as a multiply by 35. So 35 times cos of 50 is equal to x. Now again, depending on your calculators, you will be typing this in a little bit different. Either way, you should all be getting an answer of 22.5. So I can say, therefore, his kite is 22.5 meters away horizontally. The next example that I want to go through is a forest ranger is in a fire tower 120 feet above the ground. So right away, I'm just going to start drawing a fire tower 120 feet above the ground. 120 feet. She sees a fire at an angle of depression of 3 degrees. How far is the fire from the base of the tower? I'll use red for this fire. Look at this amazing fire. All right, so right away I see that there's an angle of depression of 3 degrees. Now remember, angle of depression is the horizontal and the line of sight down. So this little angle right there is 3 degrees. They want to know how far away from the fire and the base of the tower. So they want to know this. They want to know X. Now right away you can probably see the triangle that I'm looking for is right here. This 3 degrees doesn't necessarily help me where it is. So we have a couple of options. Option number 1, we can calculate this angle by doing 90 minus 3. So altogether I see that this is a right angle. So the remainder would have to be 87 degrees. So I'm able to solve this triangle now, 120 feet, 87 degrees, and find that X right here. The other option, and I'm not going to be doing it, but you could recognize that there is a Z pattern right here. So since these are parallel, if this is 3 degrees, then this little angle down here would also have to be 3 degrees, and you would be able to solve that way. It really does not matter to me which option you choose. I'm just going to go ahead and make this a little bit smaller so I can have more space to write. So what I'm going to be doing is labeling my triangle. I'm going to go ahead and I'm going to use this 87 degrees. That means that this X is my opposite, and I know this is my right angle, so I know that this is my hypotenuse over here that I don't care about, and this is my adjacent. If I'm thinking about SOHCAHTOA, I need to find a formula that uses opposite and adjacent. So I'm going to be using tan. So tan of my angle is equal to opposite over adjacent. So tan of 87 is equal to x over 120. Now again, x is on top. I'm going to bring this 120 over. So 120 tan 87 is equal to x. Let me just pull my calculator out here, and I'm going to get, give me 1 second, 120 times tan of 87 is 2,289.7 feet away. Our last and final example says that the horizontal distance between 2 hydro poles is 86 meters. So I'm going to go ahead and I'm just going to draw my 2 hydro poles, and I know that the distance is 86 meters. The angles of elevation to the tops of the poles are 14 degrees and 17 degrees as measured from a point halfway between the poles. So right away, I know that I'm looking up, and this angle is 17 degrees, and this angle is 14 degrees. What is the difference in the heights of the hydro poles? So right away, I'm just going to erase this 86. So I know that the entire distance is 86, but I also know that this point right here is halfway. We can't just assume that if it doesn't specifically say, but this question it does. So I know that this is 43 and this is 43. So right away, I know that I'm looking for the difference in height between this pole and this pole. In order to do that, I need to figure out the actual height of that pole and that pole. So I need to go ahead and I need to write my formulas. So I'm going to go ahead and label. If this is my angle, this is my O, this is my A. If this is my angle, this is my O, this is my A. So thinking about SOHCAHTOA, I can't write apparently. I have to use a formula that involves O and A, so I'm going to be using tan again. So I'm going to go ahead and find X first. So tan of theta equals opposite over adjacent. Tan of 17 equals X over 43. I have an X on top. I'm going to go ahead and bring that 43 over. So 43 tan of 17 is equal to X. And then I'm going to go ahead and type that into the calculator, and I'm going to get 43 times tan of 17, 13.14 meters. Now I'm going to do the same thing for y. So tan of theta is equal to opposite over adjacent. Tan of 14 is equal to y over 43. 43 tan of 14 is equal to y. y is equal to 43 times tan of 14, 10.7 meters. Now if I want to go ahead and find my difference, I know that I just have to subtract. So the big one, take away the little one, is equal to 2.42 meters, or 2.4 meters. Now, since this is a word problem, a therefore statement would be needed. I just don't have any room, but it would say, therefore, the difference in height of the hydro poles is 2.4 meters.